Hi everyone. Okay, here is 1.4 notes. So an acute angle measures between 0 and 90 degrees. So if we're talking about x is the angle, we would write this as an inequality as 0 is less than or equal to x, which is less than or equal to 90. Because it can't be 0 because then there's no angle, and can't be 90 because then we call it a right angle. So it is an angle that looks like similar to that. Okay. To name this angle, we'll talk about this here later. There's a couple different ways we can name it. Let's say I call this point A, this point B, and this point C. I could call this angle ABC. I could also call it angle CBA. I could actually call it by its vertex point, angle B. What I could not do, though, is use three letters and starting with B. I couldn't do BAC or BCA. The reason being is I have to go around in a circle when I'm naming it. So your vertex point, the point at which the two rays meet at, the vertex point is always in the middle. So A to B to C, or C to B to A, okay? I can name it angle B, so just with one letter, because there's not another angle there. What I mean by that is, let's say I have this angle up here, and this vertex point again is at B, right? Let's say I put another ray here. I could not just say angle B, because now I have one angle here, I have two angles here, and then I have a third angle, the big one, that all form at angle B. So you would have to be more specific and not just use one letter, but use three letters. Since there's only one angle here at point B, I can use the one letter. The other way you may see this is there may be a number in here, like 1. So I could also call this angle 1, okay? A right angle is equal to 90 degrees. A lot of times for right angle, you will have this symbol in there, the little square, to show that it is 90 degrees. In geometry and in math in general, you cannot assume anything without knowing for sure. So if I had an angle that looked like it was 90 degrees, we cannot assume that's 90 degrees unless it has that angle of 90 degrees symbol inside of it, okay? So no assumptions. Obtuse angle goes from 90 to 180, but it cannot equal 90 and it cannot equal 180. So as the inequality, we write 90 is less than or equal to x, which is less than or equal to 180. Oh, actually, there's no equal to. My fault, guys. No equal to. It's just greater than 90, but less than 180. So it could be 90.1 and still work. So an obtuse angle is bigger than 90 degrees. Okay? A straight angle equals 180 degrees. So it makes a straight line. So this would be a straight angle, making a straight line. Congruent angles are two angles that have the same measurement. So I may have my congruent angle here. So the measurement of angle 1 is equal to the measurement of angle 2. Or if I'm not talking about the measurement, I'm just talking about the angles, I may say that angle 1 is congruent to angle 2. Would be another way to say that. Angle bisector, so kind of like a segment bisector. Remember, a segment bisector cuts the segment in half. An angle bisector will be a ray that will cut an angle in half. So I may have this angle right here, which is an obtuse angle. And I may have this ray that cuts it in half. To show that, I put an arc here and an arc here to show that those angle measures are congruent. So this guy in brown would be my angle bisector. Okay. Postulate number 3, protractor postulate. It just says considered ray OB. Ray OB is down here if you can't see that. And point A right here on the side of OB. Rays O to A can be matched 1-to-1 with real numbers between 1 and 180 degrees. So they're just saying on this, essentially, you can measure an angle using a protractor. Now, if I'm talking about this angle right here, that is more than 90 degrees. So as I'm reading this, when you use a protractor, you're going to hit two numbers. You're going to hit a number that's acute and a number that's obtuse, except if you're hitting 90 degrees even. We know that this is an obtuse angle, so I have to go with the obtuse number of degrees, and that is about 140 degrees. It's hard to read that. Okay. But essentially all this is saying is that I can measure an angle on a protractor. I can match up the rays to the number of degrees. Angle addition postulate, similar to segment addition postulate. So on segment addition postulate, we had a segment, right? And we said, and then we have a point somewhere on it, and we said segment 1 plus segment 2 equals the whole segment. Well, angle addition postulate is similar to that. Angle 1 plus angle 2 equals the entire angle. Okay? And then if this line, if SP, ray SP, would have been an angle bisector, we would have known that angle 1 is equal to angle 2 also, so additional information. You obviously cannot measure these unless you have a protractor at home. But what we can do is we can write two names for the angle and then name the vertex and the sides of the angle. But we can also say if it's acute or obtuse. So number 1 would be acute. And then two names for the angle. We could call this angle A to B to C, so around in a circle. Or we could call it angle C to B to A, around in a circle the other way. We could also call this angle B because there's just one angle at that. The vertex, point B is the vertex. The sides, so ray BA is a side, and ray BC is another side. What I want for you to do is I want you to pause me, and I want you to do number 2 and number 3 the same way that we did number 1. Unpause me when you're done. Okay, so I went ahead and I did number 2 and number 3. 2 is acute, 3 is obtuse. 3 names for the angle, MOP, POM, or angle O. O is the vertex, OM is my ray, and OP is my other side ray. And then this one, EFG, or GFE, and then I could also call it angle F. F is the vertex, FE, and FG are my rays on that one. Okay, next page. Give another name for the angle in the diagram and then tell whether the angle appears to be acute, obtuse, right, or straight. So first one, J to K to M. So they are talking about, if I read it the way that they tell me, J to K and then over to N. So they're talking about that angle. I could also call that angle angle L to K to J. I could also call it angle K. I could also call it M to K to J. I could also call it N to K to J. That angle appears to be right. Number 5 is K to M to N. Okay. So that's straight angle. So that would be a straight angle. So 180 degrees, it's a straight line. I'm going to call that one, I can't call it by one letter because there's too many things down here. I'm just going to go the other way around. I'm going to call it N to M to K. Go ahead and pause me, try 6 through 9, and unpause me when you're done. Next one is P to Q to M, so it would be this guy right here, P to Q to M. I'm going to reverse that and do M to Q to P. You cannot call that angle Q, because there's too many angles at angle Q. That one appears to be either right or acute. I'm going to put acute. Next one is J to M to L. So J to M to L would be this guy right here. I cannot call that just angle M because there's too many angles there. There's also QMN. So I'm going to go the opposite way, and I'm going to call it angle LMJ, and that one appears to be acute also. Next one is Q to P to N. So Q to P to N would be from here, up here, and down. So this guy appears to be acute. I can name that with one letter, so I'm going to name it angle P because there's only one angle at angle P. And then the last one is P to L to K. So this big one. If you notice, I put different markings in each one of these. This one had 1, this had 2 arcs, 3 arcs, 4 arcs, because I don't want to put the same number of arcs. Because if this one had 2 arcs and this one had 2 arcs, that's saying that those two angles are equal. we don't know that about any of these, so I don't want to do that. So P to L to K is this big angle, so that would be obtuse. Can't call it L, so I'm going to go around the other way. I'm going to say angle K to L to P. All right. Given, use the given information to find the indicated angle. Given that A to B to C, so the big angle is 94 degrees, find just C to B to D. Before I can find C to B to D, I would need to find X. This is angle addition postulate, which states that this angle plus this angle equals the whole thing. So 3x plus 15 plus x plus 7 would equal the whole angle, which they said was 94 degrees. So combine like terms, same side. I have 3x's and 1x, so that gives me 4x's. I have 15 and I have 7, so that gives me 22. That equals 94. So I'm going to subtract 22 from both sides. So I get 4x's equals 72. Divide by 4, x equals, I think, 18. Let me just make sure I do the math right. Yep, 18. But they actually want me to find C to B to D. They want me to find C to B to D. So once I've found that, I take that x of 18 and I plug it into C to B to D's formula, which is x plus 7. So I take 18 and I would add 7 to that, which would give me 25 degrees. All right, similar process now. Q to S to D, T. This whole angle is 135 degrees. Okay. They want me to find Q to S to R, so this angle right here. So angle addition, 3x plus 1 plus 2x minus 6. I think I'm reading all those numbers correctly. Equals 135. Combine like terms, same side. So I have 5x's minus 5 equals 135. I'm going to add 5. So I get 5x's equal 140. Divide by 5, x equals 28. But now I need to plug it into Q to S to R, so this guy right here. So 3 times 28 plus 1. So 3 times 28 is 84. 84 plus 1 is 85. You should also then be able to find this angle pretty quick, because if I know all of it equals 135, and now I know this one equals 85, I just take the 135 minus that 85 to get the rest. Okay, find the indicated angle measure. So A is right here. So first off, this is 160. That means its vertical angle is also 160. Box here means this is 90. Box here, this means this is 90. Isn't it true that these two angles make a straight line together? So a straight angle is 180 degrees. If this one's 160, that leaves 20 for A. That would leave 20 for this one because they're vertical. Here I have another vertical angle. D and 75 are vertical angles, which make those equal, so this is 75. To find C, these angles together make a straight line, 180 degrees. So I take 180, subtract off that 90, subtract off that 75, and I'm left with 15 degrees in there for C, which means that this vertical angle right here is also 15. So now that we found all those, I can answer this question pretty quick. Angle A is 20 degrees. Angle B is right here, 160, because it was vertical. Angle C is 15 degrees. And angle D right here is 75 degrees. Okay. In the diagram, BD bisects A to B to C. Find the measure of A to B to C. So I know if it bisects that this equals this. Okay. Same thing here. This equals this. So what I want you to do is kind of use your knowledge of algebra and of what you've learned so far in geometry. I want you to see if you can answer questions 16 and 17. There's going to be a second video for this set of notes, so the answers and the work will be on the second video. All right, thanks, guys.